Alright class, today you are going to take the notes on section 4.1, ratios within similar parallelograms. First, a few vocabulary terms. A ratio, that's just a comparison of two quantities expressed with a phrase such as the ratio of 3 to 5, which means 3 for every 5. Such ratio comparisons are often written as fractions in a special notation. So you can say 3:5, 3 to 5, or 3 over 5. Okay, we use fractions a lot of the times because we do a lot of reducing and calculating with them, but these are the other two ways to say them as well. Okay, we use those whenever we were finding scale factor as well. We were writing ratios of the short side over the, or I should say, the big shape over the small shape and the small shape over the big shape. All right, and then a proportion is when you take two of those ratios and set them equal to each other. We're going to do some more work with proportions in this unit. Equivalent ratios are, for example, 3 to 4 and 6 to 8 are equivalent because one of them will reduce to make the other one. And then another big vocabulary word is adjacent sides. Adjacent, we talked about adjacent angles earlier. Adjacent sides are just when you have two sides that meet at a vertex. So they're going to share that corner in common. So in this rectangle, sides AB, right here, and sides AD, those are adjacent because they meet at vertex A. Now really the word adjacent just means next to each other. So they're going to share a corner, but they are also next to one another. Okay, so we're going to specifically look at adjacent sides a little bit today. First of all though, we have a bunch of rectangles here. We want to identify which ones are similar to one another. So right now a lot of them look similar. So if I look specifically at A, I notice A has the sides of 8 and 2. So as I look around, I can spend some time looking at them. Basically, I'm trying to find scale factors, something where I'm either multiplying both of those, for example, times 2 or dividing by 2, something like that. And then as I look around, I notice, G. G, I notice that the 8 and the 4 is half of 8, and then the 1 is half of 2. So 8 is similar to G. All right, now B. If I look at B, B is 3 and 4. I notice it's a little more almost like a square. So I want to find some that are a little closer together. So as I look around, I notice, F. From B to F, notice it goes from 3 to 6 and 4 to 8. That's double both of those. So B would be similar to F. All right, and then C, as I look at that one, notice the sides are 3 and 9. So I look around again, it's a little bit skinnier one. I notice that, the J, if I look at C to J, it goes from 9 to 3, that's dividing by 3 or a third as big, and 3 to 1 is also dividing by 3 or a third as big. So C and J are also similar to one another. All right, so now we're going to look at, now that we know they're similar, and I found out they were similar by looking at scale factors, right? Now we're going to look at what happens for each pair of rectangles, find the ratio of the adjacent sides. And it says to put the smaller one over the larger one. So we had said that A went with G, right? So let's write the ratio of the adjacent sides both for A as well as G and see what happens. Okay, well when I look at A, the sides that are next to each other would be the 8 and the 2. I want to put the smaller one over the bigger one. So I'm going to put 2 over 8. So that's my ratio of my adjacent sides. Okay, so now I want to look at G. I'm going to do the same thing with G. G is the sides 4 and 1, so I want to put the small one on top, 1 over 4. So the question, it says find each ratio, but what do we notice about them? Well, 2 over 8, if I reduce it, equals 1 over 4, doesn't it? So they end up being equivalent ratios to each other. So when I do the ratio of the adjacent sides, they end up being equal to each other. Now is this 2 over 8 and this 1 over 4, is that my scale factor? No, that's not my scale factor. The one's not a fourth as big as the other. This is just the ratio of the adjacent sides. But what we're noticing on this first pair is when they are similar, the ratio of those adjacent sides are going to be similar, are going to be equal to each other. All right, so let's see if that holds true on the other ones. B goes with F. So let's find the ratio of both B and F. So B, the adjacent sides on B, I would use the 3 and the 4. So put the small one on top, 3 over 4. And then if I look at F, F is 6 and 8, small one over the big one. All right, are those equal fractions again? Well, yep, it sure is. Okay, I can see that